Now we will see one more important activity, flashing on software update via diagnostics. All right, so even this software comes under the vigilance of diagnostics. Let's see how. In electric vehicles, flashing and software updates via diagnostics are critical components of electric control unit. Sorry, electronic control unit. All right, and these processes ensure the various control modules ranging from battery management system to inverter controllers and ADAS modules are up to date, secure, and functioning correctly. Let's break down the concept and execution of flashing and software update via diagnostics. All right. Now, what is flashing in electric vehicles? Now, flashing refers to the process of overwriting the existing firmware or software in an ECU with newer version, and this is done via a diagnostic communication session using standard protocols. So we have a small subtle difference between software update versus flashing. We will see the subtle difference here. First is when it comes to scope, in software updates, it is partial updates to parameters and calibration data. And when it comes to flashing, full rewrite of the firmware and software. Data size in software update, it is smaller kilobytes, and in flashing, larger megabytes to gigabytes. Use case for software update is tuning, bug fixes, and configuration. And for flashing, it is new features, security updates, complete system overhaul. And time taken is usually in the order of minutes. And for flashing, 10 to 60 minutes, depending on the ECU connection. Now, when it comes to practical tools and diagnostic, the OEM diagnostic tools, as I mentioned in the previous lesson, it can be ODS, ODIS, TechStream, and GDS2. And the purpose is OEM specific flashing and diagnostics. Now, considering the standardized tools like Vector, Cano, ETAS, and Inca, well, this means the flash via UDS, DOIP, logging on simulation, and also preparation of the GUI. When it comes to bootloader tools like hexagonal S-record flash utilities, the to write software in ECUs at bootloader level. And talking about the over-the-air platforms, Airbiquity, Aptiv OTA, and Tesla OTA framework, and the purpose is remote update management. All right. Now coming to the protocol stacks, these are very stacks. These are common. UDS on CAN DOIP, ISO 14229, ISO 15765, and it defines the communication for flashing. Now talking about the flashing update process in EV diagnostics. The first precondition is vehicle in service programming mode, adequate battery knowledge, battery voltage should be greater than approximately 13 volt, ECUs unlocked using security access, and battery diagnostic session switch to extended or programming. So these are the first conditions that must be met before flashing update starts. So next step is protocols and sessions. Now UDS 14229 over CAN ISO 15765 or DOIP is commonly used. Now this is the most common used protocol. And again, the various steps like diagnostic session control, security access, request download, transfer data, request to transfer exit, request control, ECU request. So these are the various protocols and sessions that are included in the second step. Next, typical flashing steps using the UDS. All right. So after once you take care of the preconditions, once you take care of the protocols and sessions, next comes the flashing steps. First, you establish a communication with the ECU. For example, send a small sample, send tester present or 0 by 3E. Next, switch to programming session, 0 by 10, 02 programming session, and security access challenge response 0 by 27. Next is erase memory block, OEM specific or via routine control, request download, ECU allocates memory space, transfer firmware data in chunks. Now, when it comes to transfer exit, it indicates the end of data stream, routine control to verify checksum and integrity, and reset ECU 0 by 1101 to activate new software. All right, so this is how you typically go about flashing and updating software in EV diagnostics. Now, what about the over the air update in EVs? EVs are highly connected vehicles. So I'm sure everybody knows the concept of connected vehicles. But anyway, connected vehicles is nothing but it's a part of the V2X. But explaining that connected vehicle here is beyond the scope of this particular session. But many OEMs implement OTA updates to push BMS calibration, traction control logic updates, bug fixes in ADAS logic, UI UX user interface and user experience improvements in infotainment. Now talking about the OTA process flow, update downloaded to telematic control unit and digital signatures verified using digital signatures and distributed to relevant ECUs over in vehicle Ethernet or CAN. Now talking about the ECUs enter the flashing mode, the flash occurs using the same UDS services. And talking about the reboot and the health check post flashing. So these are all the various steps in the OTA process flow. Now, what are the critical considerations? Now, before you start the diagnostics through the protocols or diagnostics through the OTA, what are the various considerations? First is the cyber security. Flashing must be protected via cyber secure boot or secure access to prevent unauthorized code. Functional safety, flashing must not violate safety goals or put vehicle in unsafe state. Now talking about the fail-safe recovery, ECUs should support rollback or partial update to ensure recovery if flashing fails. Now talking about the data integrity, CRC checks, digital signatures, redundancy checks are mandatory. All right. Now talking about the logging, this is a very important consideration. Logging, update logs are considered for audit, warranty claims, and diagnostics. Especially for future auditing or warranty claims, logging is extremely important. And last but not the least, vehicle state management. The EV should prevent charging or driving during updates for safety reasons. Now this is something you must have observed even in your regular car. Okay, for example, Bluetooth connection cannot happen when the vehicle is running. You always have to halt the vehicle to connect the Bluetooth. Likewise, the EV cannot prevent the charging or driving should prevent charging or driving during updates for safety reasons. All right. Now talking about the real world example, ETA Inca connected via CAN to EV. All right, this is a very common real world example. Okay, Inca is a calibration software and it is connected via CAN to electric vehicle. Also the battery management system BMS. Now procedure unlock BMS using UDS 027 and switch to programming session 0 by 10 02. Now talking about the flash the new SOC estimation algorithm, verify checksum and restart the BMS. Now this is the in brief procedure about the BMS update in electric vehicle. Okay, to summarize, well, first the flashing, what is meant by flashing? To override the entire firmware. What are the tools used? CANO, INCA, OEM tools, OTA stacks. Protocols, CAN, DOIP, UDS, 14229, ISO 13400. And security and safety, cyber security, rollback, logging. Rollback is nothing but going back to the previous version of the software if the latest version is having some errors. And talking about the OTA, wireless method using TCU and backend server. Okay, so hope all of you got a decent idea about this particular topic. How exactly is the diagnostic happening even through software updating? Thank you.